Welcome to my channel Lesson Physics. All of us use TV, mobile phones, computers, all of which are composed of basically a large number of transistors. So it is very much interesting to know how transistor works. In intrinsic or pure semiconductor, 4 valence electrons, 1, 2, 3, 4 valence electrons of silicon or germanium forms covalent bonds, 4 covalent bonds with neighboring 4 silicon atoms, forming an octet. Each electron is shared by each atom, both the atoms, and no free electron, and hence no conduction of electricity at 0 Kelvin. But at room temperature, due to thermal agitation, cleavage of bonds occur, free electrons move, leaving behind a vacant space called hole, positive hole. Again, recombination of these electrons and holes make intrinsic semiconductor poor carrier of electricity. So to increase the conduction of electricity in semiconductor, a trivalent element aluminum is doped or injected into the silicon wafer. Some of silicon atoms are replaced by the aluminum atom, and 3 outermost electron of the aluminum is shared by the 3 neighboring silicon atoms, but 4th electron, but it lacks by 1 electron to form the 4th covalent bond. This lack of electron constitute a positive hole, and it is called p-type semiconductor with a hole as majority carriers and electron arising from bond cleavage as minority carriers. Instead, if we dope a pentavalent element like arsenic, then the 5th electron, which is free, is negative type, and it is called N-type semiconductor. When a p-type and N-type semiconductor are joined together, abundant of electrons, red balls are electrons here, in N side flows towards p side, leaving positive donor ions in the N side, and abundant holes, these are the holes, flows towards N side, leaving negative acceptor ions in the N side. Thus, at the junction, due to recombination of holes and electrons, this region becomes depleted of mobile charges. These positive ions are attached to the silicon atoms. These negative acceptor ions also attached to the silicon atoms, so they are not free to move. So this region is depleted of mobile charges. Moreover, as this side is positive and this side is negative, a potential gradient, a potential field, a field is created in this direction. This field prevents further flow of holes in this direction. This positive repels these holes, and this negative charges repels the further flow of electrons. So this region is depleted of mobile charges, and this potential barrier prevents the further flow of electrons and holes. So Unbiased PN junction does not carry any current. They restrain further flow of any majority carriers. If we connect battery to overcome this barrier potential, it is called forward bias. That is, negative terminal of the battery is connected to the N side and positive terminal of the battery is connected to the P side. This positive terminal being connected to the P side, it repels the holes in this direction, so a hole current is flowing in this direction. This negative terminal repels these electrons in this direction, so a current is flowing due to electron in this direction. These two currents constitute a current in this direction, so a current is flowing in the forward biased diode. On the other hand, if we connect the battery in the reverse direction, that is negative with the P side and positive with the N side, then potential barrier increases. This plus attracts these electrons in this direction, this minus attracts these holes in this direction, so potential barriers is increased and majority carriers are unable to flow in any direction, so only minority carriers flow. That is, negative terminal repels the minority carriers electrons in this direction, so a current is flowing in this direction. Again, positive terminal repels holes in this direction, so a current due to hole, but these current, the current due to the minority carriers are very small, so this is called reverse saturation current. Now, transistor may be considered as two diodes back to back. Say NP a diode, another PN is another diode, back to back diode. And this is the symbol of the NPN transistor. This is emitter, this is base, this is collector. Here, this is emitter, this is base, this is collector. It is NPN transistor, so the arrow is in this direction, outward direction in the emitter. So, transistor may be considered as two diodes connected back to back. If we add a single battery in any direction, one diode always be in the reverse bias condition and block the flow of electricity. Suppose battery is connected in this fashion, that is, positive is connected to the N collector and negative is connected to the N emitter. So this diode in this time is reverse biased because N is connected to the positive. If we reverse the direction of the battery in this fashion, positive is connected to the emitter, negative N emitter, and negative terminal is connected to this collector, which is also N. So this time this diode is reverse bias because N emitter is connected to the positive. Again, no current flows, so transistor does not conduct. Transistor is in off state in either case. To have current, let us connect a second battery between base and emitter. In such a way, base emitter junction is forward biased. This N is connected to the negative terminal of the battery. This is the negative terminal of the battery, and base being P is connected to the positive terminal of the battery. The potential of this battery, although is much smaller than this potential of this battery, but it is enough to break the depletion region or potential barrier existing in between base emitter junction. The majority electrons, red balls, are repelled by this negative terminal in this direction. They are forced to flow towards the base. Again, positive terminal repels these white holes in this direction in the emitter. So, as electron flows in this direction, a current flows in this direction, and hole flows in this direction, another current flows in this direction. These two currents together with forms the emitter current in this direction. The majority electrons from the emitter are injected into the base and majority holes from the base are injected into the emitter region. These two constitute the emitter current. The injected electron diffuses through the base towards the collector junction. Base is made very narrow in comparison to emitter and collector, so that recombination between electron and holes become negligible, so that remaining electrons reach the collector and collected by the positive terminal of the collector battery. This is made narrow due to another reason, because so that electron and hole cannot get sufficient time to recombine. So only a small portion, 1 to 3% of the injected electron are lost due to recombination with holes in the base, and remaining electrons reaching the collector junction are collected by the collector, giving rise to collector current. So the difference between the emitter current and the collector current gives the amount of the base current. This small base current is due to the flow of electron from the base of the battery, base to battery, to maintain the charge neutrality of the base. So base current being very small, and that is the input current is very small, and collector current is very large, it gives rise to current amplification of the transistor. This is called beta is equal to IC, collector current, divided by IB, the base current, which gives rise to current amplification factor. This is called current amplification factor. So transistor can be used as current amplifier. Thanks for the patient hearing. I hope it is interesting to you. Thanking you again